Hello, algebra students. This is the extra video for those of you that missed a little bit of a lesson because you were taking the quiz. If you've seen it already and you want to go through it, it's not bad because it'll reinforce the learning. If you haven't seen it, again, this isn't required. That doesn't mean you shouldn't do it because it's going to make your life easier when you come to factoring. Now, the methods I've taught you about factoring with grouping are really good methods. Sometimes there's a faster way. We're going to see if we can discover it. All right, so first of all, let's only worry about the black problems, and I'm going to go ahead and shield the screen so you can't see the red problems anymore. So I just want you to worry about the black problems, and would you please double distribute this, okay? So, that would mean going x times the quantity of x minus 5 plus 5 times the quantity of x minus 5. And I'm going to tell you, if you're doing it like this is a good way to do it, but it's actually too much work. You'll see what I mean in a minute. So now I'm going to distribute the x, and I'm going to get, an x squared, right, minus a 5x. And then I'm going to distribute this 5 here, and when I do that, I get a plus 5x and a minus 25, right? And then I'm going to combine my like terms, and I'll get x squared minus 25, okay? Notice that the positive 5x and the negative 5x canceled out. That's what I meant about doing too much work. See, these here are going to cancel each other, right? And there won't be an x term. Well, that's going to happen anytime it looks like you have the same quantities except one of the signs is different. So on this one, I've got a 3x plus 11 and a 3x minus 11. I know automatically that my middle terms are going to cancel out those x terms. So I'm just going to multiply the 3x times the 3x and get 9x squared. And 11 times 11 will be 121. If you don't believe me that it's 9x squared minus 121, go ahead and do it this way, which is a good way to do it. Nothing wrong with that. And watch, you'll get a 33x, a positive 33x, and you'll also get a negative 33x, and they'll cancel out. Okay, now one thing I want to point out here is there's some special numbers here. You see, you've got this x squared, this 25, this 9x squared, and this 121. They're all very special numbers. And if you don't realize it, they're perfect squares. Yeah, they all have a square root. So if I take the square root of x squared, I get x, and the square root of 25 is 5. Hey, did you notice that the original problem had an x and a 5 in both quantities? Yeah, that's not a coincidence. 9x squared is a perfect square. If I take the square root, I get 3x, and the square root of this is 11, and look at that, I get a 3x and 11 in both quantities. The only difference is one's positive, one's negative. Well, I can use that idea to help me factor. When I have a perfect square minus a perfect square, this is called the difference of perfect squares. It's a factoring pattern. It'll make my life easier. Difference of perfect squares. If I give you a problem like this on a test, before you know this pattern about difference of perfect squares, you have to multiply 16 times 81, which, on a calculator isn't hard to do, but then you got to find factors of that number that cancel out, right? Okay, well, we can try that. Let's do it that way. All right, so I'm going to do 16 times 81, and I'm going to get 1,296. Now, I need these two factors, whatever they are. I'm not going to list them all. That's insanity. These two factors, whatever they are going to have to subtract to get 0. Well, it's going to have to be the same number. That means 1,296 must be a perfect square. So I'm going to take the square root of 1,296, and look, I get 36. So I could go 16x squared plus 36x minus 36x minus 81. And I could do my grouping thing, right? And this isn't really too hard to do. I mean, it's not that it's difficult. It takes a few minutes. Okay. So let me see. The GCF of this is going to be, I think, 4x, right? So I'm going to get a 4x. And so I'll have 4x times the quantity of 4x plus 9. And then here I'm going to factor out, I think, a negative 9. Yeah, I think I'm going to do a negative 9 here. Kelsey, if you're watching, they're both positive in this first quantity. They're both negative in the second quantity, so I want both signs to change. That's why I'm doing a negative 9 instead of a positive 9. So I get a 4x plus a 9. Ooh, those match. I'll pull that 4x plus 9 quantity out. I'll be left with a 4x minus a 9. Now, that's not too bad. That's a pretty typical problem. But watch how much quicker it can go if I recognize that I have the difference of perfect squares. Okay, so first of all, I ask myself, well, the difference of perfect squares will only happen with a binomial. It's got to be a binomial. Okay, now it could happen inside of a problem, but it's got to be a binomial, whatever part you're looking at. So is 16x squared a perfect square? It sure is. What's the square root? Well, 4x. Is 81 a perfect square? Yep, and 9. Here's how this factors. 4x plus 9, quantity, and a quantity of 4x minus 9, and I'm done. See how simple that is? The other way is a great way to do it, but it's a little bit longer. Go ahead, you try it on this one here. 25x squared minus 36. Okay? Hopefully you've tried it. If you didn't know what to do, you could always back up the video. I'm stalling for you so you can try it. I really want you to try it on your own because you're not going to learn it just by watching me. Got to try it. All right, square root of 25x squared is 5x. Square root of 36 is 6. I'll need a 5x plus a 6, a 5x minus a 6, and I'm done. Yeah, it's that easy. All right, now remember, it has to be subtraction. There has to be subtraction. So, how about this one? The negative x squared plus 49. Is it a subtraction problem? Some of you don't think it is, and I disagree with you. Some of you say, well, I guess it could be subtraction if I rewrote it. And how would you rewrite it? Oh, you might rewrite it like this. 49 minus x squared, right? Well, the square root of 49 is 7. Square root of x squared is x. I'm going to need a 7 plus x quantity and also a 7 minus x quantity. And there you go. Pretty simple stuff. All right, 25x squared plus 9. Go ahead, give it a shot. Give it a shot. 25x squared plus 9. Are you having trouble? Did you think the answer was 5x plus 9? Oh, excuse me, plus 3. And then maybe 5x minus 3? Were you thinking that was the answer? Because if you are, I fooled you. Because if I double distribute this, when I get to the point where I'm going to multiply, hold on, I lost my highlighter, pressed the wrong button there. Sorry about that. When I double distribute, at some point I'm going to have to multiply this positive 3 and this negative 3, right? When I do that, aren't I going to get a negative 9? But up here I have a positive 9, so that's not going to work. All right, so then what happens is you start to guess and check, which is not really a smart thing to do, but I've seen so many kids do it. All right, so they're going to go plus 3. All right, so now they're going to get a positive 9. But when you do that, when you multiply the 3 times 5x, you get a positive 15x. And when you multiply this 5x times this 3, you get a positive 15x. You get a positive 30x by combining like terms. It doesn't match. If you haven't figured it out, this one's prime. You can't factor it. Why not? Because it's not the difference of perfect squares. No, there's no subtraction sign. There has to be one negative. So this one is actually prime. Okay, it can't be factored. Its only factors are 1 in itself. Okay, you can do something called the quadratic formula on it, see if it has any solutions, but we're going to get to that later. All right, let me give you one more here, and I got to warn you, it's going to be a two-tiered. All right, so we're going to go, hold on a second here, I'm having a little trouble. My shade must be covering up my extend page. Oh, maybe because it's shaded, I can't extend the page. There we go. All right. I want to give you one more problem, and that'll work. So let's go with x to the 4th minus 1. Okay. Now, is x to the 4th a perfect square? It sure is. X squared, right? 1's a perfect square. So I'm going to need an x squared plus 1 and an x squared minus 1. And many of you will stop right here. Only problem is, look at this. Look at just, where's my shade? Shade, where are you? Look at just this part. Uh-oh. Come on. Look at that. That's an x squared minus 1. That's a difference of perfect squares hiding inside of the problem. This needs to be factored further. So the square root of x squared is x. Square root of 1 is 1. So it's going to be an x plus 1 as a quantity and an x minus 1 as a quantity. And then the x squared plus 1 comes down with the problem. Yeah. See that? Hey, one more. Difference of perfect squares. Just to mess with you. All right, let's see here. Let's go with 12. Let's even make this x cubed. Yeah, let's make it x cubed. 3x cubed minus 12x. Now, right off the bat, some of you are so smart going, wait a minute, I thought you said you were going to do the difference of perfect squares. You don't see a difference of perfect squares. But what's the first type of factor you should always try? GCF, right? I see a GCF. I see a 3x as a factor of both those numbers. So I'm going to factor out the 3x, and I'm going to get an x squared minus a 4. And look at there in the middle. Don't I have a perfect square minus a perfect square? So this part factors further. Yeah, it sure does. The square root of x squared is x. The square root of 4 is 2. So I'm going to need a quantity of x plus 2 and a quantity of x minus 2. And this 3x. And there is your answer. Yeah, multiple tiered. Right. Okay. Now, the other part we're going to talk about is called a perfect square trinomial. We're going to start very much like we did on the other one by double distributing. And again, you're probably going to do too much work at first, but I'm going to go x times the quantity of x plus 5 plus 5, hello James, times the quantity of x plus 5. Are you going up to watch Charlie Brown?
Yeah.
Okay.
I want you to come right now.
I can't, I'm in the middle of the video.
What
I can't pause it. Channel 5. Okay? All right, so I'm going to double distribute. I will. Double distribute, right? So I'm going to get an x squared plus 5x plus 5x plus 25. And these middle ones turn into a 10x. And there you go. You just double distribute it. Now the reason I'm saying you might be doing too much work, when you see it's the same exact quantity twice, you're going to get 3x times 3x, 9x squared. Yeah, I'm doing the second problem. 11 times 11 is 121. It's going to be positive. You're going to get a 33x and a 33x, and so that's going to be a 66x, and I believe it's going to be a negative, right? Now, there's nothing wrong with the other way, just trying to point out some faster ways to do stuff. 66x. Okay. Now, not unlike the last problem, there's some perfect squares hiding in here. I see a perfect square here. I see one here. I see one here. And I see one here. Now, they're a little different because of that middle term. So if you didn't catch this on Friday, the square root of x squared is x. Square root of 25 is 5. 5 times x is 5x, doubled 10x. Ooh, it matches. Square root of 3x squared, 9x squared is 3x. Square root of 121 is 11. 3x times 11, 33x, doubled 66x. Look at that. These answers are in the form of what we call perfect square trinomials. We can work backwards on them if we recognize we have a perfect square trinomial. So let's try it. Is this 16x squared a perfect square? Sure is. Square root is 4x. Is 81 a perfect square? 9. 9 times 3 is 36, so we got 36x. And if I double 36, sure enough, I get 72, don't I? Here's how it factors. The square root plus the square root. And I have two of those quantities. How did I know the plus? Because, and this confused Bailey on Friday, hopefully she's catching on, if there's a plus in the back, it's the Wendy's double stack. This guy shows up twice. He shows up here, and he shows up there. Okay, so if there's a plus in the back, it's the Wendy's double stack. The middle sign will show up in both quantities. Okay, let's try this one. 25x squared plus 36. Well, is that a perfect square? It sure is. Square root is 5x. Perfect square? Yep, 6. 5x times 6 is 30x. Times 2, 60x. It's a perfect square trinomial. I'll get a 5x and a 6. A 5x and a 6. Hey, look at that. I got a plus in the back, don't I? You see my plus? There's my plus right there. It's the Wendy's double stack. This guy will show up twice. So it'll be 5x minus 6 and 5x minus 6. And if you don't believe me, you can double distribute. Okay, so now let's try this red one here. Perfect square, yep, square root is x. Perfect square, yep, square root is 10. X times 10 is 10x. If I double it, I get 20x. This is not a perfect square trinomial. Okay, this one doesn't fit the pattern. So on this one, I'd have to multiply 1 times 100 to get 100 and list some factors. 2 times 50, 3, 4 times 25, 5 times 20, 6 isn't going in, 7's not going in, 8's not going in, 9's not going in, 10's going in. But I need to add to get 10. Not possible out of these numbers. If I add these two, I get 20, 25, 29, 52, 101. This is prime. Prime. It looked like a trinomial. It looked like, I should do the perfect square thing, but it fooled me. Then I went to the grouping thing, where I try to write it as a polynomial with 4 terms and group them, but I couldn't come up with the factors. Okay? All right. Here we go. You try this one. You try this one on your own. I'll play some music to help you think. Do 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 do. You can stop the music anytime you want. Do 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 do. All right, there you go. Now you know I don't teach music. Let's see. Is it a perfect square trinomial? If I take the square root, I get 4x. Take the square root of this term, I get 7. 4x times 7 is 28x. If I double 28x, sure enough, I get 56x. It is. So I get 4x and 7. And you know what? On this one, if you're Damon Hendrock, you might like to do this instead of writing the same quantity twice. And that's perfectly okay. You can write it twice, or you can put to the second power. Now, let me see here. Where's my highlighter? I have a plus in the back. I don't know if you noticed this on the perfect square trinomials. You always have a plus in the back. And on the difference of perfect squares, they can always be written so that there's a negative there. Okay, so there is a plus in the back. It's the Wendy's double stack. And I'm going to put the plus sign right there. Okay, if I wrote it twice, it would look like 4x plus 7 and a 4x plus 7, both in quantities. All right, that's it for the video. If some of you had a rough time on the quiz, on the retake quiz, especially on problems 1 and 2, which should have been the easiest, mainly in my first period class, my second, 7th, and 8th period classes didn't show as much difficulty. If you would like to come in at lunch, okay, those of you that got, scores of like 10 or 11 or 12 or even 13 out of 18, let me know, because problems 1 and 2 should have been cake. The problem is you're not looking to GCF first. And I think if I spend just about 10 minutes with you telling you to GCF first, you're such good students, you're going to figure it out and you're not going to make that mistake anymore. So anyway, Mr. Lawrence signing off. Have a good night, everybody.